Okay, in homework 1 we're going to work out some values of absolute values given a range. So here we can see we've got x bigger than 5 is given, and we want to find the value of the absolute value of x minus 3. So the important thing of all of these is to decide if it's positive or if it's negative. And the easiest way to do that is to substitute a value. So let's pick, let's say 6. So if we put 6 in for x, or substitute it, we have 6 minus 3, and that's positive. So we know that if we have a positive value, then the absolute value doesn't change. So for just as a quick example, if we have the absolute value of 3, which is positive, well, that's 3. But we know that if we have a negative absolute value, then it just changes to positive. And we've seen that in the piecewise function as well. So here it's, if we know that the inside function is positive for our domain of x, then we can just write down exactly the same expression on the inside. We know it doesn't change, so it's equal to x minus 3. So let's look at b and do the same thing. We've got the same range, x bigger than 5, so let's pick, let's say 6 for x. In this case, we'd have 3 minus 6, which we know is negative. So in this case, we're going to reverse the positive negative symbols here. So it'll be positive x minus 3. And so we've simplified and we can see that those answers are correct there. All right, so question 2. Let's say x is 8. So if we substitute 8 here for x, let's see, are these positive or negative? 8 minus 3, well, that's positive. And 6 minus 8, that gives us minus 2, which is negative. All right, so now let's write the expressions. The positive expression remains the same in absolute value. A negative expression, so the x will become positive. So let's say positive x minus 6. And now we can group the like terms together. We've got x plus x, and that will give us 2x. And then the numbers, we've got minus 3 minus 6, that gives us minus 9. So there's our answer there. In question 3, we're looking at a really important idea, and the range that's given here are the breaking points. So the breaking point here corresponds here, minus 2 is the breaking point of this absolute value, or the 0 value, and 5 is the value for the second absolute value. So we're looking for the range, or the domain in between there, those x, the interval of x. So let's see if we substitute. Let's pick, I don't know, 0 for x and determine if these are positive or negative. So this will be positive, 0 plus 2. And if we have 6, sorry, that's a 0. 0 minus 5, that's negative. So that inside part there is negative. So now let's write the expressions. The positive expression doesn't change, x plus 2. We're still multiplying by minus 3, so let's put brackets because we're multiplying all of this inside expression. So the 5 will be positive and the x negative, and then the rest of the expression remains the same. And we'll just write it out there. So now we need to use the distributive law. So minus 3 multiplying the 5 and the minus x, we get x equals x plus 2 minus 15 plus 3x, negative times a negative, and the same at the end. Let's look for our like terms now. We've got x, positive 3x, minus 4x. Okay, so they're all going to cancel because they add to 0. And we have minus 2 minus 15 is minus 13. Minus 7 gives us minus 20, as we can see. And for question 4, we're asked to find the absolute value of all of these numbers. So, okay, all right. So minus 7, I think we can say safely that that's 7, because remember the negative value up here gives a positive. 5, well, that's positive. So for these expressions now, 3 minus root 3, we have to decide what's root 3 about. So we know that root 3 is definitely less than root 4. And we know that root 3 must be less than 2. All right, so we've got 3 minus something that's smaller than 2. Well, it's never going to be negative. That's always going to be positive. So here we can say that expression will be positive. So in absolute values, nothing changes. If we have now minus 5 plus root 5. So let's decide here. Root 5. What do we know about root 5? We know that root 5 is bigger than root 4. So root 5, we just pick a convenient square root close to 5. So 4 was convenient because that's a perfect square. So root 5 is bigger than 2. So if we take minus 5, we add something that's bigger than 2, but not that much bigger than 2. it's certainly less than root 25, isn't it? So this bit would have to be negative because this minus 5 is a lot larger than root 5. So a negative value in an absolute value makes this positive, so switch the signs. 5 will be positive, root 5 negative. And for 3 minus pi, I think we can agree that pi is 3.14, about 3.14, so that's bigger than 3. If you subtract something bigger, that's going to be negative, so the pi will be positive, and 3 negative. And you can see those answers there. All right, now question 5, just reinforcing that point in question 3, we've got the breaking points here are the breaking points of the two absolute values. So let's substitute a value in here. For fun, let's pick 1 this time. So if we have 1 plus 2, that's going to be 3, which is positive, and 1 minus 5 is going to be minus 4, which is negative. So just some extra practice rewriting these expressions. The positive expression remains the same. The negative expression changes. So we have the 5 is positive, the x negative. So if we simplify this expression, we've got, well, the x minus x gives us 0, and the 2 plus 5 gives us 7. So remember the important concepts here, that the positive section of the absolute value remains the same, the negative value returns a negative value. You could think about this as minus 3 to give the positive.